Welcome back. We're still in section 1.6. We're going to build on what we learned the last couple of nights from lesson 1.5 and lesson 1.6 day 1. And we're going to use the sign rules for adding, subtracting, multiplying, and dividing signed numbers. But we're going to use it inside an application of translating keywords and phrases that imply multiplication and division into mathematical expressions or sentences. Remember the difference between an expression and a sentence. A sentence always has an equal sign. Sentence always has an equal sign. So it'll have words like is or equivalent to or is the same as, okay, or equals to. All right, expressions won't have those kinds of phrases. All right, so let's go ahead and I'm going to hit my highlighter and let's go to the next page. All right, again, I'm going to just review the operations for signed numbers. When we're doing addition, if they're the same sign, you're going to add those two numbers together and then use the common sign. Okay, an example of that would be if I wanted a positive 3 plus a positive 2. That's going to be a positive 5. Okay? Same sign. Positive 3, positive 2. If I wanted to do negative 3 plus negative 2, okay? They're both negative, so I take the numbers, 3 and 2, combine them, add them, and then use the common sign, negative 5. Okay? If we have a mixed sign, okay, one is positive, one is negative. Positive and a negative. You end up taking the difference of the numbers, and then you use the sign that you have the most of. For example, if I have negative 4 plus 5. Okay? 4 is negative, 5 is positive. So I take their difference, and then I use the sign that I have the most of. I have 5 positives. That's bigger than 4 negatives. So it's more than. So that's a positive 1. If I have 2 plus negative 3, okay, I'm adding mixed signs. So I take their difference, and then I use the sign that I have the most of. So I have more negatives. All right? Remember with subtraction, okay, we made it easy on ourselves, and we said, well, subtraction is really just adding the opposite. So I'm going to change all my subtraction problems to add the opposite. And it's a good idea to start thinking in terms of subtraction is add the opposite. And then I'm going to apply the rules of addition. All right? So if I have 2 minus 3, I'm going to rewrite that as 2 plus a negative 3. And then I'm going to apply my rules of addition, which we did up here, and that was negative 1. Okay? If I have 4 minus a negative 2, I'm going to say that that is 4. I'm going to change it to addition, and I'm going to add the opposite. 4 plus 2 is 6. Okay? Now, with multiplication and division, if you have the same sign, let me get my highlighter, same sign, your product is always positive. So a positive times a positive, or a negative times a negative. They both give you positive numbers. All right? Mixed signs, if you have mixed signs, then your product is always negative. So if I have negative 5 times 2, that's going to give me a negative 10. Okay? If I have negative 10 divided by 2, that's going to give me a negative 5. Remember that division by 0 is always, always, always undefined. Can't do that. You can't take a group of 2 objects and divide them equally among 0 groups. Okay? You at least have one group of 2 objects. So that is just physically impossible in the universe. Okay, so now that we reviewed that, now let's start looking at the keywords and phrases, okay? Now remember, we're looking for words and phrases that imply multiplication or division. So let's start off with the obvious, okay? If you have the key phrase, product of, that's going to tell you to multiply the 2 things together. So it might say the product of negative 3 and negative 8. That's nothing more than negative 3 times negative 8. You have a negative times a negative, which is going to give you a positive. And then 3 times 8 is 24, just like that. Okay? This would be the translation. This would be the answer if they ask you to evaluate. Another word that implies times or multiplication is times. Times. 12 times negative 3. 12 times negative 3. You're going to multiply those 2 numbers together. You have a positive times a negative. That gives me a negative. And then 12 times 3 is negative 36. Another phrase that implies multiplication is twice or double. You could also think of as tripled, quadrupled. Tripled would be multiplied by 3. Quadrupled would be multiplied by 4. Okay? You're multiplying whatever number follows the word by 2 if it's twice, by 3 if it's tripled, by 4 if it's quadrupled. So twice 6. Twice implies 2 times 6. 2 times 6 is 12. Okay? Of with fractions is saying multiply the fraction by whatever number follows. Okay? So 1/2 of 10 says multiply 1/2 times 10. 1/2 times 10 is nothing more than 10 divided by 2. 10 divided by 2, which equals a positive 5. Percent of is also implying multiplication, all right? Percent of 12% of negative 16. Well, 12% is 12 parts out of 100. So that's, sorry about that. I think my arm is hitting something here. My bad. All right. I have 12 over 100, okay, times negative 16, okay? 12 out of 100 is 0.12, okay? If you didn't know that, you could just go 12 times negative 16 and then divide by 100, okay? And then 12% of negative 16 is equal to a negative 1.92. As much as is also an expression for multiplication. I'm here. 3/4 as much as 28. So all that says is take 3/4 and multiply it by 28. All right? I'm not going to use a calculator on this. I'm going to cancel. 4 goes into 28 7 times, and 3 times 7 is 21. So 3/4 as much as 28 is 21. Okay? Now quotient We've learned this before. Quotient, the quotient of 15 and 5 just says the first number goes in the numerator, the second number goes in the denominator. 15 divided by 5, and that equals 3. Okay? Why don't you try, hit the pause button, you try divided by and ratio of, and come back and see if you got them right. All right, welcome back. 9 divided by 7. That is just 9 over 7. Okay. 9 has factors of 3 and 3, which neither one of them go into 7. So that is as simple as it gets. The ratio of 2 to 3, that's just 2 over 3. Same order, 2 to 3. Numerator first, denominator second. The ratio of 2 to 3, all right? And that is simplified. All right, let's try and do a couple of these with some examples, all right? And then they want us to simplify it or get it down to a number, okay? The product, that says I'm going to multiply something, 12 and the sum of 3 and negative 6. So I have 12 times the sum of 3 and negative 6. Okay, I have to do what's in the parentheses first. So 3 plus a negative 6, that's 12 times a negative 3, and I get negative 36. Twice, that's 2 times the difference. Remember, the difference says I subtract in the order that I read them. So it's 2 times 8 minus 4. Twice the difference, okay? So I have to put parentheses around it, okay? Okay, so 8 minus 4. 8 minus a negative 4. Hold on one second here. I need to erase that. 8 minus a negative 4. 8 minus a negative 4. Okay? 8 minus a negative 4 is really add the opposite, 8 plus 4. So I get 2 times 12, which equals 24. 2/3, that's just a fraction, 2 over 3, of the sum. So that's 2/3 times the sum of negative 5 plus negative 3. So I have 2/3 times negative 8. And that gives me negative 16 thirds. Remember, I just multiply the numerators together. 2 times negative 8 is negative 16. And 3 times, there's nothing in the denominator, so that's a 1. 3 times 1 is 3. And that's as reduced as we can get it. Okay? All right. You try D&E and see if you can come back and see if you got it right. 15% of the difference between 14 and negative 2. 15%, well, I know that is 0.15. If I didn't know that, I could write it as 15 over 100. 15 parts out of 100, right? So I have 0.15 of means multiplies. So the difference between 14 minus negative 2. So I get 0.15 times 16. This is add the opposite. And I get 2.4. double, that means it's 2 times the product of 3 and 4. Well, 3 times 4. So I'm going to multiply 3 times 4 together, and then I'm going to double it. So that's 2 times 12, which equals 24. There's your answer. Okay? All right. You guys want to try A and B and come back and see if you got them right. All right, welcome back. Quotient. On my chart, quotient says I'm going to be dividing. Quotient of, my first number is my numerator, 14, divided by the sum of negative 9 and 2. So I get 14. I have mixed numbers that I'm adding, mixed signs, right, that I'm adding together. So I take their difference, and I use the sign that I have the most of. I have more negatives. 14 divided by negative 7. I'm dividing mixed signs, so it's negative 2. I can reduce top and bottom by 7. Okay. B, the product of, product says multiply, the product of 5 and negative 6 divided by the difference, so here's a division, divided by the difference between negative 7 and 8, okay? So this has to be my numerator. So I have 5 times negative 6 divided by, there's my big division sign, the difference between negative 7, difference means subtract, minus 8. Okay? So 5 times negative 6, I'm multiplying mixed signs, so I'm always going to get a negative. And 6 times 5 is 30. Right? On my denominator, I'm going to change this to add the opposite. So I get negative 7 plus negative 8. That's a negative 15. Now I have a negative divided by a negative. My rule tells me that becomes positive. And then 30 divided by 15. I check to see if 15 goes evenly into 30, and it does. So I divide top and bottom by 15, and I get 2. Just like that. Hopefully you got that same answer. All right. Okay. Now, I alluded to this when we started talking about our objective for today. Remember that phrases translate into expressions, but sentences translate into equations. Sentences will have an is. They could have equal or equivalent to. Okay. So 3 times a number. Remember in our previous lessons, anytime we saw a number, we were going to put in the variable x. Okay. 3 times x is, that's our keyword for equal, 16. If they asked you to, I haven't done that yet. Okay. The sum of a number, that's going to be our x, and 9 is, there's our equal sign, okay? So I have x plus 9 is equals 12. You try C and D on your own, and then come back and see if you got them right. Okay, welcome back. Difference, that means subtraction. There's that key phrase, a number, so that's where we're going to put in our variable. The difference between a number and 5 is 0. Okay, so this has to be written in the order that we read it. X minus 5 equals is 0. Okay. Quotient, this means division. Okay, see that? Division. We're going to do, the first number goes in our numerator. The second number goes in our denominator. The quotient of 24, oops, here's our second number is a number, okay? 24 divided by x is equal to -2. Okay? All right. Part of your homework, there's like 4 problems tonight, and they go through the divisibility test. So I'm just going to touch base with them quickly. A number is divisible by 2 if it's even. So if the last digit is even, then it's divisible by 2. 8 is the last digit, 8 is even, so it is divisible by 2. A number is divisible by 3 if when you add up the digits, sum of the digits is divisible by 3. So if we take the number 963, I add 9 plus 6 plus 3, that equals 18. 18 is divisible by 3, so this number is divisible by 3. Okay? A number is divisible by 4 if the last 2 digits form a number that's divisible by 4. So here, 24 is divisible by 4, so 1,224 is divisible by 4. We've learned this one lots of times. The number is divisible by 5 if the last digit is 0 or 5. This last digit is 0, so this number is divisible by 5. A number is divisible by 6 if it is divisible by both 2 and 3. Both 2 and 3. So we have to check both divisibility rules. This number, 37,482, ends in 2. That's even. So it's divisible by 2. And now to check to see if it's divisible by 3, I'm going to add those digits up. 3 plus 7 is 10, plus 4 is 14, plus 8 is 22, plus 2 is 24. 24 is divisible by 3. So this 37,482 is divisible by 6 because it's divisible by both 2 and 3. All right? The divisibility rule, a number is divisible by 8 if the last 3 digits form a number that's divisible by 8. So 1,104, I'm going to concentrate on 104. If 104 is divisible by 8, then 1,104 is divisible by 8. And this number it goes in 13 times. So this number, 1,104, is divisible by 8. And it's actually 138. 9, if the sum of the digits are divisible by 9. Okay? So it's similar to 3. The sum of the digits had to be divisible by 3. Here, the sum of the digits have to be divisible by 9. So add up the digits. 1 plus 2 is 3, plus 4 is 7, plus 5 is 12, plus 6 is 18. 18 is divisible by 9. So 12,456 is divisible by 9. And this last one down here, it's divisible by 12, and I can't really get in there and touch it if the number is divisible by both 3 and 4. So you have to use 2 divisibility tests, okay? So I'm going to add up my digits. I did that. It's 18. 18 is divisible by 3, so we know 3 works. And then to see if it's divisible by 4, I'm going to concentrate on the last 2 digits, 56, and 56 is divisible by 4. So 1,002 12,456 is divisible by 12. Why? Because it's divisible by 3 and it's divisible by 4. All right. This is the homework that we're going to be working on in class tomorrow, so come prepared, ready to do that. These are new concepts that we talked about in this lesson. The summary exercises. This is going to be anything from, I believe, 1.5 and 1.6. So have both sets of notes available to help you if you need it. All right, see you tomorrow. Thanks for listening.